Okay, so hello guys. So today we are going to do exercise 3.6 of exercise 3.6 of just a second exercise 3.6 of l.devore probability and statistics for engineering and sciences. Okay, so let's move on to 3.6. So 3.6 deals with possible. So let me just explain you the 3.6 quickly. So I'm just telling you 3.6 in here. Okay, so just a second. Okay. Oh man, yes. So the Poisson. Okay. So the Poisson probability distribution P of x equal to x e to the power minus mu to the power x. Okay, so first, so let x be a random variable. Okay, so the Poisson probability distribution would be, the formula of Poisson probability distribution is this. Okay, so here this is exponential, this one is random variable, this one is mean. And this rule can be applied only if n is greater than 50. N is what? N is total number of events. So n is the total number of total number of events. Total means total sample size. Okay, I will tell you. And NP should be less than 5. So what are the conditions for this? The conditions for this is n is very large, n should be large, and p is very small. So this is the sample size, and this is the probability of success. Okay, and of binomial if large, b, x and p. Okay, so if this thing, I will tell this. Okay, so in binomial distribution where b of x and p, where b is the probability of number of success, and p is the probability of number of success, and p is the probability of success in a single trial. So p is what? P is the probability of success. P is the probability of success in a single trial. So if p is the probability of success in a single trial, and what is b? B is the probability of number of success. So I'm telling you number of success. Let me explain you number of success. So like if you toss a coin, and success of getting head for each trial, the probability of getting, okay, so for getting head in each trial, so let's see, if you toss a coin, not biased, unbiased coin, what would be the probability of getting head? It would be 0.5. And if you want to find the probability that we want 5, 4, 3, 2, 1, 0 heads, that's PMF of the B, which is this. So B is basically probability of number of success, and P is the probability of success of each trial. Okay, so now if in B, X and P we let n tends to infinity and p tends to 0 in such a way that np approaches a value mu greater than 0. So if in B, X and P we let n tends to infinity and p tends to 0 in such a way that np approaches a value and mu is greater than 0. So you have to note that if you have a binomial random distribution where n tends to infinity and p tends to 0, p is what? P is the probability of getting success in each trial, and n is the sample space, then it would just be transformed into this. Okay, so so now what is the standard deviation? So what is the standard deviation now, guys? Standard deviation is root over of np. Okay, so standard deviation is root over of np. Okay, why? Because the mean is np and variance is also np, so standard deviation is also root over of np, because we know that sigma is equal to root over of mu. No, sorry, root over of yeah, I'm right. Variance, sorry. Sigma equal to root over of v of x, and here both are same. Okay, what is the hint to know if it is Poisson distribution or not? Poisson distribution mentioned in question, so it would be mentioned in the question. Okay, and the value of e would be given to you, like e to the power minus something. If it is given, then it's Poisson, because we had e here. Okay, now how to identify. Now let's see some questions in which we can we will see Poisson distribution. Let's see some uh, let's see some okay, let's see some type of questions in which Poisson distribution would be there. So it would be there in it would be minimize. Okay, so it would be there in number of, like it would be like in the question, where could it be there? It would be there in number of phone calls recorded. So if there are if number of phone calls means so number of phone calls recorded would be very large, because n is very large here. Now similarly, it would be there in number of accidents. It would be there in number of accidents, because again p is very small, because accidents are very small. Number of print mistakes in a, so again p would be small. Print mistakes in a good book. Number of deaths due to rare disease, so again deaths would be less, because it's also rare, so p would be again small. So now let's move on. Number of defective products in factory, so again it would be small, so that's why we can use. Okay, now exercise, let's do some exercise. Okay, so I will just give you some. Okay, you can just pause the video and try some exercise. Let's see question number 82. Okay, let me show you question 82. 3.3 minute exercise. Okay, so in the question it has given us, consider writing onto a computer disk. So it's telling us consider writing onto a, just a second, let me just switch it off. Okay. Consider writing onto a computer disk and then sending it through a certifier. So assume that we have, just a second, I have received a call. Okay, just a second. Okay, let's solve some question. Okay, so in question 82, consider writing onto a computer disk. So assume consider that we are writing onto a computer disk. Okay, and then sending it through. Okay, let's also just take the solutions here, because I'm just going to teach you. I will just show you the solution, because first you have to pause the video. You have to try it by own, try it on your own. Then you have to look at this, look here and to the solutions of it, which I will be showing you. Okay, so just solve the 82 number question. Just pause it and solve it by your own, or then I will just, then you can just go through it. Okay, so consider writing onto a computer disk. So let consider writing onto a computer disk. Okay, and then sending it through a certifier. So first we wrote onto a computer disk, and then we are sending it to a certifier that counts the number of missing pulses. Okay, suppose this number x has a Poisson distribution with parameter mu equal to 0.2. Suggested. Okay, this one is the source. Okay, so first of all, it's telling us consider writing onto a computer disk. So you are writing on a computer disk means changing something in a disk, and then you are sending it to a certifier. So you're sending it to a certifier that counts the number of missing pulses. So okay, let me just, I also don't know the context, so basically it's study with me, so I will also just see it. Okay, so that you will understand better. Okay, so I will also just make you understand the context much better. Being here. Okay, so the classic statistic problem model, quality control testing, number of flaws, missing data. No, not this. Come on. Okay, so just a second. Okay, Gemini. Let's just open hypergeometric. Just begin here. Okay, let me, I will explain you better. Explain this in simple words. Okay, I'll just explain you from here. Okay, so consider writing onto a computer disk and then sending it to that. I think we understood up to this. Okay, I don't know what do you mean by missing pulses. Okay, let me search here. Missing pulses meaning in CDs. Sorry. CDs. Okay. Yeah, have I not? Yes, I have. Okay, in technical context relating to a CDs such as combined data set. No, not this. What it is showing me. Okay. Okay, let's understand it better from here. Think of this as a quality control test for physical data storage. Think of this as a quality control test for physical data storage. So for let's say, think of this as a quality control test. Okay, just think of it as a quality control test for physical data storage. So if you want to store data physically, okay, this is basically quality control test. Okay, writing onto a computer disk, you save data onto a disk. The computer records this data as a series of tiny electronic or magnetic signals called pulses. Okay, so basically it's a tiny electronic and or magnetic signals. The computer records. So basically, see, writing on a computer disk means you are saving data onto a disk. Okay, The computer records this data as a series of tiny electronic or magnetic signals called pulses. Okay, it's not CD, it's not compact disk, it's computer disk. Okay, and it's basically a quality control test for physical data storage. So when you are saving data onto a disk, the computer records this data as a series of tiny electronic and or magnetic signals called pulses. The tiny electronic or magnetic signals, which actually the computer is recording this data as a series of tiny electronic or magnetic signals called pulses. Okay, sending it through a certifier. You put the disk into a specialized inspection. So you basically put the computer disk, into a specialized inspection machine. The certifier. Okay, so it's not a person. You just put the disk. Which disk? You put the computer disk into a specialized inspection machine. Sending it to a certifier. You just put the computer disk. Sending it to a certifier. You just put the computer disk, the specialized inspection machine, certifier, to test whether the disk works properly or not. Okay, so certifier is just setting a website or something like an application. Okay, counting machine pulses. The machine scans the disk. Okay, so what are pulses? Pulses are the electronic or magnetic signals. Okay, which records data onto your computer disk. Counting machine pulses. The machine scans the disk. The machine scans the disk to check if any signals. So the machine scans the disk. Counting machine pulses means machine just scans the disk to check if any signals fail to record because of tiny flaws or defects on the surface. Okay. 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 Let me read it again for you. Counting machine pulses means the machine scans the disk to check if any signals fail to record because of tiny flaws or defects on the surface. A missing pulse simply means a spot where the signal was supposed to be saved but wasn't. Okay. In short, you save data onto a disk. In short, you save data onto a disk, and a testing machine checks for defects by counting how many signals failed to save. Okay, it's just for checking. You don't need to go deep dive into it because it's not a part of your focus. Okay. So let me just see, just one second. I want to know, and you may also know what is certifier. Just open something else. Yes. Certifier in PC for checking computer disk. Just a second, check it for you. To check your computer disk healthy or certify drive errors, you can use built-in Windows tools like trusted third-party diagnostic software such as, and these programs are no bad sectors. Okay, so RD is in the computer itself is an application or a hardware which we have to buy. This is, I know it No, an application software. So is disk certify or security for computer disk is an application software, not a piece of hardware you have to buy. Okay, let's just focus here now because it's not related to our focus. Okay, so consider writing onto a computer disk and sending it through a certified that counts the number of missing pulses. Okay, suppose this number x. So this is the let me just write here. Okay, just suppose that this number x has a Poisson distribution with parameter mu equals 0.2. Okay, so what is x? X is the number of missing pulses. Okay, so consider writing onto computer disk and sending it through a certifier and it counts the number of missing pulses. Suppose this number x has a Poisson distribution with parameter mu equal to 0.2. Let's suppose yes. So let x equal to what? X would be, tell me what? X would be number of missing pulses. Okay, and now we have what is probability that disk has exactly one missing pulse? Okay, so we have to find. Let me write here. Not a part. This is a part. Okay, to find p of x equal to 1 because missing pulses is 1. So that's it, I think. Okay. We are also given mu equal to 0.2. Okay, so we are given mu equal to 0.2 and what more we are given? Okay, so now let us find the p of x equal to 1. So if we use the formula which was e to the power minus mu to the power x. Okay, if we use the okay, so you can calculate it by using the formula. Okay, so I haven't screen shared, right? Means I haven't gone to that window. So if you want to, yes, so x would be 1, e to the power mu is what? Mu 0.2 and gain 0.2 and x is 1 and x factorial would be what? Number of missing pulses, it was 1. Okay, 1 factorial. So if we just use the calculator, just a second, I'm bringing my calculator. Let me calculate it. E to the power okay, why am I calculating it? This you don't need to calculate. Okay, let's just see the solution instead, find the solution and check it. We are right. Okay, or else okay, no, let's check it. 82a. So yeah, okay, so it has done something else. Okay, it used it did by using cumulative distribution. Okay, so cumulative distribution, if you know, is just so when it is doing f of 1, it is basically doing p of 1 plus p of 0, and when it is doing f of 0, it's doing f of p of 0, and it's using 0.2 because if you remember in notation, okay, so if you remember, I don't think you have. Okay, if you remember this notation, it's 1 and 2, 0.2. If we will write here mean value, it's 0.2. It was 0.2. Okay, just see here, it was 0.2, so it's just notation. Okay, so let's just calculate it the value, or else I'm just showing you how can you just write it. Okay, so just a second. Okay, so notation I think is here. Okay, so here we write the mu value. So this is the notation x semicolon mu. So it's just, I just wrote the same thing, but it has written the f. Okay, so we have f. Do we have you can see here also x is 3 and u is 3, right? Okay, so these are the you don't need to actually look here. Okay, let's just okay, I can also, so if you want to actually verify, you can just show you the appendix, because it's there here, it's here actually. Yeah, this one. So if you see, it is in cumulative Poisson probabilities, and the denotation is fx semicolon mu. So yeah, it is 3.5. Just go to supplementary. Yes. Okay. You can do by just looking at the appendix, which is actually, you just look at the appendix and solve it. But we will not solve by that, because an exam I think will not get the appendix. Okay, so let me just solve it for you. Yes, I'm using the scientific calculator. Let me just solve it. So e to the power minus 0.2 yeah. So e to the power minus 0.2 multiplied by 0.2 divided by 1, which is not necessary. So 0.16. So we are getting 0.164. So is it the answer? Let's see it. Am I wrong? No, I'm correct. Okay. So similar answer, 0.163. Okay, now let's move on to the B part. Let's make it fast. We are late. Okay, what is the probability that a disk has at least 2 missing pulses? So what is the probability that disk has at least 2? So today P of x at least 2 means what? Greater than equal to 2, right? So which should be equal to what? 1 minus, right? So one more thing, why is it Poisson? Because obviously we are counting the number of missing pulses, so it would be very less. That's why. Or you can also see in the question, it is also asked as it's given Poisson distribution. By that also you can know it, right? Okay, so x is less than equal to 2, so we have what and what. Okay, so so I will just show you the denotation, because why not? So this is the denotation. For f also the same denotation would be there. For f also the same thing would be written. Okay, so we'll just write it for, we'll just write here f of 2 comma 0.2. And if you see the appendix table, just get the answer by seeing the appendix table. So let's just see what it has done. So it has done the same thing. Okay, just a second. I think I made a mistake. Okay, sorry, I'm so sorry, I made a mistake. So it would be p of x greater than 2 means what? 2 and other values. So you have to just take the less than 2 values. So p of x less than 2 means, which means equal to 1. Okay, so it would be 1. And if you see by appendix table, it was 0.982 and we get the value 0.18. Okay, if I just show you, how will it be 0.982? So if you calculate it, f would be what? F would be p of this one. So let me, if you use the formula again, formula would be e to the power x by x factorial, and for board it would be 1, and again e to the power minus mu, which would be same, so we can just we can just common it out because 0.2, right? And mu to the power x, so 0.2 to the power what? 1, 0.2 to the power 0, which would be 1, right? Okay, so because if you want to verify, we had written the formula here. So mu would be 0.2, x would be 0, so it's e to the power minus mu into 0.2, which is e to the power minus mu is what? What is the value of e? Actually, I'm just forgetting the value of e. So let me tell you what is the value of e. It's basically 2.718. Okay, 3. You don't need to remember because you will get a calculator. Okay, so it would be okay. So then let me just calculate it. Power minus 0.2 times 0.2, which would be 0.1637. Okay, I think I'm wrong. Okay, where did I go wrong? Hey, right over here. It was the formula right? Formula is absolutely right. What's my mistake? Okay, guys, can you just find the mistake? Okay, so can you just okay, can I just wait just a second, let me just share it again. Oh man, set. Just a second. I don't know how, but Okay, so what happened? Okay, yes, so again, okay, I think this stops here, it's not that clear. Okay, can it be much clearer? Yes, so okay, let's leave it. Okay, so now I made a mistake. What is the mistake? Let me just calculate again. Because what is the mistake? Okay, let me calculate again. Recalculate it. If I make again, if the mistake happens again, I will just skip it. It's equal to 0 plus p of x equal to, let's make it fast. So p of x equal to 1 would be, so what would be the value of this e to the power, and it would be mu to the power x 0.2 to the power, and 0 factorial is 1, 1 factorial is 1. Okay, so actually we have the value p of 1, so why are we calculating it again? It's 0.163. We need to calculate this. 1, so it will be minus 0.2 plus 0.163. So about 0.2. Okay, minus 0.2. Okay, so now I think I've got the right value. 0.8187 plus 63 0.981. So it's close. It's too close. Where was the value? Okay, no, it's not close. Okay, I think I made some mistake again, because okay, no, I'm right. 0.982. Sorry. I'm right actually. So the value here is 0.982, which is f of 1 semicolon 0.2, which is 0.982, and this is 1. So this is 0.018. Okay, so yeah, I'm right. Okay, so 0.018 is the answer. Okay, let's now move on to the next part. So what is the Sieg number says? If the two disks are independently selected, what is the probability that neither contains a missing pulse? So if the two disks, like, what was the x? X is the x. What is x? X is what? X is the number of missing pulses. It's telling us if the two disks are independently selected. Okay, so if the two disks are independently selected, what is the probability that neither contains a missing pulse? Okay, so this is for one disk, right? Consider writing on a computer disk. So this is for one disk, right? Consider writing onto a computer disk and then sending it through a certifier that counts the number of missing pulses. Suppose this number x has a probability distribution with parameter mu equal to 0.2. This is for one disk. Now if two disks are independently selected. So what is the probability that neither contains a missing pulse? Okay, so we have to find out p of x equal to 0. So we had already find out p of x equal to 0. Okay, so we had already find out p of x equal to 0, which was this. So it was p of x equal to 0, 0.8187, and if it is for 2, the probability that two disks don't have missing pulses we'll just multiply it and use the calculator. Okay, now we have got 0.6702. This is the answer. Let's just check the value. Okay, so very close, 0.671. So we are right. So it just, if you can see, it just did this. It has written many things over the disks contain 0 missing pulses, p of x equals 0. Okay, it has find it out. Since the two disks are independent, p of 1 doesn't intersect, 2 doesn't. So basically what? Basically you have to find that two disks doesn't have missing pulses. So basically you have to find p of x equal to 0 for pulse 1. Intersection means what? Intersection means and, right? Union means or. If you want to check, if you think I'm wrong, you can check here. Intersection means and. Okay, it includes only the items. Okay, intersection means and. Okay, so basically intersection means both. If both doesn't satisfies, it becomes 0 for binary. If both satisfies, it becomes 1. If one doesn't satisfy, if one doesn't satisfy, it becomes 0. If it needs to satisfy both to become 1. And if you just compare it with union, in union any one could satisfy any one of the two if it satisfies. Like if you have 0 union 1, if any one of the two satisfies, right? If any one of the two satisfies, it becomes 1. Sorry, it was just. So if any one of the two satisfies, it becomes 1. So if 0 union 1 is what? 1. 0 interaction 1 is what? 0. Right. So since two disks are independent, because both are independent, because there is no relation between them, they are not dependent. Okay, so if both disks are independent, first doesn't intersect, second doesn't, so we just multiply it, get the answer. Now okay, let's just create, I think you have one doubt which you should have, that I didn't tell you about. Number of missing pulses. What do you mean by the number of missing pulses? No, means we know that pulses, writing on computers, you just save data onto a disk. So see, what is x? What is x? Number of missing pulses. Now let's see what is pulses. Writing on computer disk, you save data onto a disk. the computer writing on a computer disk. Okay, let me just switch off the camera. I don't need it actually. Let's switch off. Do you need that? It's unnecessary. Okay. So writing onto a computer disk, you save data onto a disk. The computer records this data, a series of tiny electronic or magnetic signals called pulses. Running on a computer disk, you save data onto a disk. So you are just writing on a computer disk. So there's a computer disk and you are writing on it. You save the data onto a disk. You save the data onto a disk. The computer records. You save data onto a disk. You save the data in a disk. The computer which is there, because it's computer's disk, the computer records this data as a series of tiny electronic or magnetic signals. So these tiny electronic or magnetic signals are called pulses. So basically the data is being saved by tiny electronic or magnetic signals called pulses. Let me repeat last time. So when you save data onto a disk, you are basically writing on a computer disk. The computer records this data as a series of tiny electronic or magnetic signals called pulses. So the computer records this data, which you want to save onto a disk. The computer records this data, a series of tiny electronic magnetic signals. Called pulses. Now let me show this to you. Consider writing onto a computer disk and then sending it through a certifier that counts the number of missing pulses. So when we talk about missing pulses, we are just talking about the missing. So what is pulses? It's the electronic or magnetic signals. The computer records this data, means you save the data onto a disk, the computer saves this data as a series of tiny electronic or magnetic signals called pulses. So when you're talking about missing pulses, you're talking about missing electronic or magnetic signals, which means you're talking about computer records. So the computer records will not store it because this is missing. If this is missing, so let me just write it again. So writing on a computer disk. So you're writing on a computer disk, you save the data onto a disk. Okay, you save data onto a disk. Okay, so I will just write it over here because for clear understanding, you save data. This is let us draw a computer disk. This is a computer disk. Okay, let me just show you. This is a computer disk. Okay, let's say this is a computer disk. You save the data, or add it. What sound come out? Or add data by what is written here. You save data onto a disk. The computer records this data, a series of tiny records. As computer, I will just show you. Records this data. So the computer records this data as series of tiny electronics, or magnetic signals. Electronic or magnetic. The computer records this data as a tiny electronic. Let me write it complete. Electronic or magnetic signals called pulses. Let me write it neatly. Okay, so basically when you just save data or add data, the computer records this data as a tiny electronic or magnetic signals. That tiny electronic or magnetic signals is called pulses. So when we talk about missing pulses, this is I wrote this. This is computer disk. Let me write it neatly again. This is computer. You also note it down. This is computer disk. You understand the concept. Okay. You save data or add data. save data, right? Because you save data, you save data onto a you save data onto a disk. The computer records this data as a series of tiny electronic or magnetic signals called pulses. Okay, so this is computer disk. Computer disk, you save data or add data. Computer records this data as a series. Okay, as a series, of tiny electronic and magnetic signals. That these magnetic signals and tiny electronic signals are called as pulses. So if you're missing pulses, if you're missing this, let me write it here. If you're missing pulses, you are missing the data. Okay, so if you're missing pulses, if you're missing pulses, if you are missing pulses, you are missing data. Why? If you're missing pulses, you're missing data. Why? Because the computer records this data as a series of tiny electronic magnetic signals. So if you're missing pulses, you are missing these magnetic you're missing tiny electronic or magnetic signals, so you are missing data. Okay, that's it. Let me just not make it much more. Let me not expand it much. Okay, so let's just take a break. Okay, and we will just continue. Okay, so guys, let's continue. Right, we have taken a huge break. Let's continue. Okay, so where were we? We were. Uh, let's just. I'm just screens. Okay, I think you can hear my voice. Yes, all set. Okay, so this is the. Yes, let me just screen share. Yes, so guys, let's this one. Okay, so let me just. Yes. Okay. Okay. Ready? So let's continue. Okay. So question 83. Okay, or let's just go to question. Okay, not take it will not take much time. Let's go move on to question 83. So the question is asking us an article An article in the Los Angeles Times, December 1993, reports that 1 in 200 people, 1 in 200 people carried a defective gene that causes inherited colon cancer. Okay, so uh, so okay, so guys, okay, what we had discussed previously that n should be greater than 50. Okay, so here n is 200, so it's obviously greater than 50. If you want, I can show you again. Okay, so we had discussed here n should be greater than 50 and it's also greater than 50. So if n is greater than 50, so which is 200, so if it is 200 and greater than 50, an article in the Los Angeles Times reports that 1 in 200 people, so 200 people means n is greater than, obviously it's greater than 50, carry a defective gene that causes inherited colon. It causes defective, so because of that defective gene, it causes, just a second. Okay, let me write it down. Because of that defective gene, so because of that defective gene, because of that defective gene, because of defective gene that causes, because of a defective gene that it causes inherited colon, it causes inherited colon cancer. Okay, so because of a defective gene, causes inherited colon. So one person. So if 1 in 200 people carried a defective gene that causes inherited colon cancer, so one person has colon cancer out of 200. In a sample of 1000 individuals, so let's n is 1000, which is obviously greater than 50, right? And in a sample of, okay, so in a sample of 1000 individuals, what is the approximate distribution of the number? What is the approximate distribution of the number who carry this gene? So basically, what it is asking us, what is the approximate distribution? What is the approximate distribution? What is the approximate distribution? So basically it is asking us P of x. What is the approximate distribution of the number? What is the approximate distribution P of x of the number who carry this gene? Use this distribution to calculate the approximate probability that between 5 and 8 inclusive carry the gene. Okay, so first of all, why it would be? See, because it's not given us and it is poison. Okay, so how will you know it's poison? We can know it's poison. We'll know it's poison by. So here the E value is also not given. E is also not given because I had told you if E is given it's poison, but here E is also not given, and again poison is also not named. Okay, so how will you know it's poison? So you will know it's poison by simply. Let me just do this. You will know it's poison. You will know it's poison by simply. How will you know it's poison? We know it's poison by looking that here we have 200 persons. By looking at that, the n size is large. N is very large because if n is greater than 50, it's poison. This is going to be applied only if n is greater than 50. So n is greater than 50, and np if you multiply. Okay, so what is the probability also? What is the probability that people carry the gene? An article in Los Angeles, people report in the Los Angeles. An article in the Los Angeles Times, 1903, reports that an article in the Los Angeles reports that 1 in 200 people carry the effective gene. Reports that 1 in 200 people carry the defective gene. So if 1 in 200 people carry a defective gene, so probability would be 1 by 200. Right, so probability is so small. That's why it's poison. And we can also know it by it can be applied only if NP is less than 5. Okay, so if you multiply 1 by 200 times 1000, it would be nearly equal to 5. So yeah, it would be. Okay, so let me just show you. Okay, so this was the rule which I had told you earlier. This was the rule, right? This one and this one was the rule. So what is the P? What P value is 1 by 200? And what is the N sample space? It's 1000. So if we multiply this 2, we will get 5. So it's nearly equal. And obviously we have N as 1000, which is greater than 50. Okay. Now the question to you is, what is the probability? What is the probability? User is going to calculate the approximate probability that between 5 and 8 inclusive carry the gene. what is probability that people carry the gene are 5 between 5 and 8 inclusive? Okay, so we have to find out. The first of all, let's write the p. Okay, so p value is, so you, so because of defective gene, it causes inherited colon cancer. It causes inherited colon cancer. So now it has, so because of defective gene, it causes inherited colon cancer. So if 1 in 200 has defective gene, then 1 in 200 also has colon cancer. So and Hubble space is 1000 and p is 1 by 200. Okay, so now if the question has between 5 and 8 inclusive carried a gene, so means they also have the colon cancer between 5 and 8 colon cancer. So find it out. So it would be p. What would be the values? P of 5 plus p of, write it better. X equal to 5 plus p of x equal to 6 plus p of x equal to 7 plus p of x 8. Okay, so let's find out p of x equal to 5 and okay, just a second. Okay, this. Okay, so if you say the formula, we will not write it again. I will write it again. To minus mu to the power x by x factorial. V to the power minus mu to the power x by x factorial. Okay. E to the power minus mu to the power x factorial. And okay, so we will write the summation sign, and it would be x from 5 to x equal to 8. Okay, so yeah, so we'll just take out e to the minus mu. We will just take out this one, and mu is what? Mu is, okay, so the mean is not given, I think. Or is it given? No, it's not given. So how will I find? Yeah, find how we will find it out? Okay, so we can find it out by just, okay. Sorry. I'm extremely sorry. So yes, how we will find it out? I'm extremely sorry. So we'll just find it out by window multiplication. So let's just find mu here. Mu would be equal to NP. So which would be equal to 1000 by 200. 1000 by 200 would be 5. This was only mu. Okay. This is mu actually. Okay. So let me just write it over here. Right? This is the mu value. And now let me just make it complete. 8. And let's just write the mu value, which is 5. Yes. So let's just make it complete. 5 to the power 5 plus 5 to the power 6 plus 5 to the power 7 plus 5 to the power 8 by 5, 6, 7, 8. Okay, so this is actually a long calculation. So let's just tell our Gemini. Okay, let me show you what. Let's find it from our phone with Gemini, using Gemini. Let's use Gemini Live because it will be faster. Okay. So Gemini calculate this value. Which one? Which value? This one. I'm telling about this value. See, just a second. This value. See Gemini. This value. So it's I think you have heard it, guys. It's 0.4914, and I just check the value. Sorry. Okay. So the value here is question 83, part A, and the value is same 0.4914 or 0.492. Okay, so what it did is it just did a simple calculation by just using the appendix value. So in appendix, you'll get this value. You will get this value. You will also get this value. Just subtract it and you will get this. But in exam, you will not get that, right? Now let's calculate the remaining part B. At least 8 carry the gene. So P of X, at least. So okay, 1 minus P of X. Okay, 1 minus P X less than X, then it's 7. And so Gemini, so sorry, so guys, so this would be the answer, because let's see what it has written. I think it's just did f of c. It's written same thing, but it just used you know what, appendix, and we got this one, right? So 0.867, we got this one. Then subtracted it and got this one. Let's just read this. The exact distribution of x is binomial with n equal to 1000. The exact distribution of x is binomial. With n equal to 1000 and p equal to 1 by 200, we can approximate this distribution by a Poisson distribution with mu equal to np equal to 5. So it's telling us the exact distribution of x. Okay, so did you got it? Because because this is approximate, because we actually saw this is actually deep thing. Okay, this is, we are going deep here, but it would just take a small span of time. Okay, because when we did np, which was 1 by 200 times 1000, we got 5. Okay, so it should be less than 5. np should be less than 5, but it shouldn't be equal to 5. So if it is equal to 5, it's binomial, right? So, and actually it's binomial, because written in the exact distribution of x is binomial with n equal to 1000, p equal 1 by 200. But we are approximating. We can approximate this distribution by the Poisson distribution with mu equal to n p equal to 5. That's it. It's actually perfect. This is a good line. This is it's a deep line. Okay, then actually good. Okay, so just note it down because it could be helpful, right? Yes, let's just note it down because it would be helpful for you. Okay, so important, I'll mark it important. Okay, so np is equal to 5, and for Poisson it should be less than 5, but it's 5, but equal to 5, so it's binomial, but we approximated it to Poisson. Okay, that's it, right, guys? Let me just make it a bit larger. Okay, so this is important, so just note it down, guys. Okay, just pause it and note it down. Okay, so now let's continue. So So let's just see this. If you want to actually see this, f of 7 5. If you want to see this this is because this is basically cumulative Poisson distribution. Okay, Poisson distribution. But if you want to actually look at the value of this in appendix table, so let's look at it because you want to. Okay, there is always a curiosity, right? But the curiosity comes with a time frame to complete your syllabus, right? So let's just look at it. Let's make it fast, right? So it's B part, P of x greater than equal to 8. So the answer. Okay, just a second. Let me charge my laptop because it's a laptop, right? Just a second. Okay. Yes. So this is the cumulative Poisson probabilities. Let's see the mean values. So if you want to just know about it, these are the mean values. This is the x. We have not mean. We have mean of 5. Okay, it's up to 15. Yes, because by not right. But after this, it's becoming binomial. Okay, just leave that all, or else. Okay, for 5, if you just see for 5, it's we have what? We have mu equals 5. Yes, we have mu equals to 5 and n equal to 1000. No, p equal 1 by 200. So what we had, just a second. Before this column, we have to look at the value of x. Okay, so x would be what? X would be less 7 because this is cumulative, so x would be 7 because this one is because 83. Yes, because this one is 7, this one is 5. Okay. So 5 and 7. 0.867, right? 0.867 is the value. 1 minus 0.867 is the value. Okay, and NP should be less than 5. So yes, so NP should be less than. So NP should be less than 5, and NP is mu, and mu is 5, right? Mu is 5. Mu value is 5. So if you just look at the appendix table, it's again 5 mu value, and okay, now you may be wondering why these all are also the mu values. It shouldn't be greater than 5, right? It shouldn't be greater than 5. Yeah. This is actually binomial, but we have approximated it to Poisson, right? We have approximated all these values to binomial because if you go more, you don't get it. See, after 20, you don't get the appendix table. Telling you after 20, you will not get the appendix table. So we have approximated it. Okay. So from 6, 7, 8, 9, 10, 15, 20, these all values are actually binomial, but we have approximated it to Poisson, right? So, so 7 and 5 is 0.867, right? So this one, let's move ahead. Okay. So let's just write 0.867. 1 minus 0.867 would be equal to what? It would be equal to 0.133, right? Okay, let's move ahead. Next question. Let's move ahead to the next question. Supplementary exercises. Okay, let's see here. 3.6. Sorry for the noise, background noise, but I can't do anything. Okay, because I'm not a teacher. I'm a student who is just teaching you, helping you, because nobody on YouTube is teaching this book, right? but his book questions are very important. Nobody on YouTube is teaching it, so I'm just helping you. Right. So let's move ahead. So we have done this 83B. We have covered it all. Now we are at the question 84. Right. So let's solve the question 84. The Center for Disease Control and Prevention reported in 2012 that 1 in 88 American children, 1 in 88, I'm writing it, 1 in 88, the Centers for Disease Control and Prevention reported in 2012 that 1 in 88 American children had been diagnosed with an autism spectrum disorder. In order reported 1 in 88 American children had been diagnosed with an autism spectrum disorder, ASD. Okay. So if an random sample of 200 Americans, so what is n here? N would be 200, right? I'm just writing it here. I'll just show it to you again. N would be 200. On the A part, if a random sample of 200 American children is selected. Okay, so n is greater than 50, right? If a random sample of 200 American children, and what is the probability? It would be, okay, so first of all, what is the x? What is x? What do you think? X is the number of children who have been diagnosed with an autism spectrum disorder, right? So x would be what? X would be what? Tell me. It would be number of children diagnosed with an autism spectrum disorder or ASD. Okay, n is 200. So what is p of x? P of x means what? Now we are diagnosed with ASD, so p of x would be 1 by 88. And if you know better than me, 1 by 88 would be, from calculator, it would be 1 by 88. It would be 0. I'll just show you, don't worry. 0.01136. Okay. And now what would be NP? Because n value is greater than 50. Sorry, n value is greater than, right. N value, yes. N value is greater than 50, right? Just cross check because, yes, n value is greater than 50 and NP value, because n is very large here, n is 200, it's large, and b is greater than 50. Sample size, and p should be very small. Here p is also very small, 1 by 88 is nearly 0, right? And NP, let's just check the NP value. Is it less than 5? Okay, so let's just check the NP value. So NP value would be NP. Let's just take the mean. We have to also find it out. So let me just show you. So this is the sorry. Yes. So this is the 84. I've written the 1 in 88. X is the number of children diagnosed with ASD. P of x is 1 by 88. So it is this much. Very small. It is very small. N is 200. And mu NP would be equal to what? Tell me. 200 times. So what is the value of P? 0.01136 or 1 by 88. So 200 by 88. Calculate it and tell me. 200 divided by 88. 200 divided by 88 is what? 200 divided by 88 is how much? It would be 2.272. Okay, 2.273. Rounding off. Okay. So it is obviously less than 50. Very much less than 50. Okay. Because we had this, right? Because we had this one. Right? And we less than 5. Okay. Sorry, not 50. 5. I'm extremely sorry. So it's very much less than the value 5. And it's very large and P is very small. P is very small. We have seen it's nearly 0. And N is very large. It's 200. Means Large means what? It should be greater than 50, and it is greater than 50. Okay, so now one more fact I want to tell. Yes. Uh, okay, so 5:15. Okay. Okay, I want to actually see this because I want to just. I mean, I want to be perfectly sure, right? Make it faster. Yes. So all these were actually approximated. Okay, you don't no need to look at this because I had a doubt. You don't have that doubt. You don't have that doubt. You don't need to look at it. Okay. So let's move on to question 84 again. So let's a part. Random sample of 200 American children is selected. What are the expected value? Standard deviation. And a number. What are the expected value? Means sigma and standard deviation. Okay, so I think I'm wrong. Expected value is E of x. What is the expected value and standard deviation? We number who have been diagnosed with ASD. So expected value would be mean variance standard deviation. Standard deviation would be just root over of mean, we had calculated standard deviation, right? Right, and expected value would be E of x, and E of x would be right. E of x. Let's just see it because I have forgotten. Okay, so because I'm student, right? I'm just explaining it because none of none of teachers on YouTube are explaining this, right? So, uh, where were we? Just a second. Expected values, right? 84. Yes, 84. 84. The binomial, the expected binomial, wait. No, not, it's not binomial actually. Wait, p equal to, because it is in 5. We had calculated it. It is less than 2, it's 2.273. It's way less than 5. Not binomial. I think it's wrong. Okay, with 188 mu is equal to NP. 2.27 sigma is equal to, oh, it has done it as binomial. How do you just make it binomial? Right. 2.27. Okay. It's nearly the same thing, right? And it hasn't calculated the expected value. Okay. Just a second. Let me just check. Expected value. I think we can just check it once. Check it for once. Expected value. Yes. Yeah. I'll just see here. What was that? I just forgotten. But I just. Okay. It's just mean. It was just mean. Sorry. Right. It was just mean value. Mm. I'm extremely sorry if you think I have done some. I made a problem. Okay. Just the mean value x times p of x. Right. Right. Okay. We can also ask Gemini. Is expected value the mean value is the expected value just a mean value?
Yes, the expected value is the theoretical mean of a probability distribution, representing the average outcome you'd expect over the long term.
Yeah, so you heard the Gemini, right? Guys, you heard Gemini. So it's the same thing, right? So, okay. So 2.273 is the expected value, is the mean. And standard deviation, if you can't see that. Yeah, what is the sigma? Okay. Yes, so you. Yes, and sigma would be equal to root over of NP, which is equal to root over of 2.273, which would be root over of 2.23. Okay. Which would be, okay, sorry. Root over of, I'm just calculating it by calculator, 2.273. Okay, so it is 1.5076. Right. Nearly same. Okay. X has approximately a Poisson distribution. And the question is asking us another question is asking us 84b. Referring back to A, calculate the approximate probability and at least two children in the sample have been diagnosed with ASD. So now we have to find, referring back to A, calculate the approximate means, by referring means taking n as 200 and calculate, that's it. Calculate the approximate probability that at least two children in the sample have been diagnosed with ASD. So P of x equal to 2. Sorry. So it would be equal to, what was the formula? Can you just tell me? It was, sorry. What was it? Tell me. It was, it was e to the power minus mu into mu to the power x by x factorial. E to the power minus mu times mu to the power x by x factorial. E to the power x, right. So just put mean value, which is 2.273. Okay. And mu value is again 2.73 square by x value is what, 2. So 2, we'll just write 2 because 2 factorial is 2. Okay, or else you can just write 2 factorial. We'll just later on make it 2. Right. So let me just calculate it by calculator. Okay. Right. So now E value, here is the mic on. Okay, yes, it's on. So E, let me get the value e to the power minus 2.273 would be equal to 0. C would be equal to 0.103 times this one would be, okay, just a second, 2.273 square, which is equal to 5.166 5 by 2. So it should be equal to what? Times 0.103 divided by 2 equal to 0.266. Right. Okay, let's just check the solution manual. So it is okay. So we have made a mistake, I guess. Okay, I think we have made a mistake, right, guys? Mistake we had made. Okay, I think it's at least. I have to calculate the approximate probability at least. Achha, okay, so I'm extremely sorry. It's not 2. We have wasted our time. What can I do? I'm sorry. So referring back to A, calculate the approximate probability that at least two children in the sample, at least. So I hadn't given the emphasis on the word at least. Calculate approximate probability that at least two children. Calculate approximate probability that at least two children in the sample have been diagnosed with ASD. So, I'm sorry. So, these are all wrong misdeeds. Okay, so just forget it. Okay, so let's read have this value. X greater than equal to 2. At least 2 or more than 2 because at least is written at least 2 children in the sample have been diagnosed with ASD. So 2 should be the minimum limit. 1 minus p of x less than 2 or equal, we can say 1 minus p of x. It would be 0 comma hyphen. If you don't know notation, let me tell you notation. Notation is this. Okay, p of x hyphen mu is the 2 point. Okay, so I'm not sure whether it is small p or capital P. Just let me just check it for you. Okay, just a second. Come on. It's small p. It's small p, right? Right? Okay, I'm sorry. Okay, so if you calculate this value, it would be this is basically sigma. Okay, let's just read this. It would be sigma x equal to from 0 to 1 would be e to the power minus mu times mu to the power x by x factorial. I think I'm right. 2 minus mu divided by x factorial 2 minus mu to the power x by x factorial. Now it will mu will be taken out of the box. E to the power x factorial. To power mu would be minus 0. Minus 2.273. Let's write it again. Okay, mu to the power 0 would be 1. Would be again 1, so 1 plus. Yes, because 0 would be 1, right? E to the power 0 is 1. Mu to the power 0 is 1. And anything to the power 0 is 1. And 0 to factorial is 1. So 1 plus 2.270 to the power 1 divided by x would be what? 1 factorial, which would be 1. One minus this. Let me calculate this value. So we got this value. Let's check if it is equal or not. Yeah, nearly it's equal. 24, sorry, 24b, sorry. Yes. So very close, 0.6622. Right? The exact binomial answer is 0.6645. So it is telling us also that, referring back to a calculated approximate probability, that at least 2 children in a sample have been diagnosed with ASD. So if the question is taking binomial as the valid, as the valid, if the question is taking binomial as the valid one, means as the valid one, then the approximate would be Poisson distribution, and mu would be 2.27, and p of x is, if p of x greater than equal to 2 would be this much. Okay, and it would be 0.3378, right? Which I had got 0.337. It has got 0.3378. So now it has got 0.663 or 22. Exact binomial answer is 0.6645. If you just go by the binomial one, it would be 0.6645. Okay, let's now move on to the question number 85. Sorry, 84. Is it completed? I guess no. Okay, we have part C also. If the sample size is 352. Now let's say we have n as 352. What is the approximate probability that fewer than 5 of the selected children? So probability would be fewer than 5, means x is less than 5. What is the probability that fewer than 5 of the selected children have been diagnosed with ASD? So if we just find the mean again, because we need to then find the mean. So NP would be, and so if you just here, NP would be 352 times probability would be what? N is 352, probability would be, we had got, yes, probability was 0.0. Okay, this was the probability. Let me copy it. Just paste here. So times 0.01136, which is 3.99, means less than 4. Mean approximately 4, which is again 5, but n is increased. But p is the same. N is increased, so n is large, like we had written over here. N is very large and p is very small. P is, I think, p is constant. N is increased, and then p should be less than 5. So it is much more Poisson. We don't need to focus on that, right? Okay, so it would be f of 4 0.0. Okay, sorry, you have to write the mean 4. Okay, this is the answer, and yes, this one is the answer, right? So if you see the mean, it's 4. P of x less than 5 would be f of 4, come on, 5 semicolon 4, which would be, yeah, basically 0.629 from the appendix table. And if we solve it, we will get, okay, we have to solve it again because the mu value has changed. Okay, we can just solve it, or we just write the formula. Let's not solve it, just put the values. X equal to 0, right? 0, because it would be not 1. 0 to 4. it would be e to the power minus mu, which mu is 4 times mu to the power x. No, x should be changing, right? By x factorial. Right, so this one was the value e to the power minus mu, which I wrote it here, to mu to the power x, which is 4 to the power x. Okay, and x factorial. Just take it, we'll just take e to the power minus for us. Take it out, we'll just take it out, and it would just be this much should remain inside sigma or summation. Right, and you have to just solve this value. Let's move on to the next question. Okay, so question 85. Okay, suppose small aircraft arrives at certain airport. Okay, where we okay, let's just do one. Let's skip one question and do this one. This one. Okay, let's move on to question 86. Okay. Organisms are present in ballast water discharged from a ship to a poison process. So this is poison distribution because it's written poison. According to a poison processes with a concentration of 10 organisms per meter cube. This is the so this is the source. Considers using poison processes for this purpose. Okay. Right? Just a second. Yes. Okay. So organisms are present in ballast water. So organisms are present in, I will show you, I'm writing in my tab, present in organisms are present in ballast water. This is from a ship to a poison process with a concentration of, so what are the concentration? 10 organisms are present in 1 meter cube. So now let me show you this. Okay, what is happening here? Yes, let me show you this. Okay, not this. Just this. Yes, let me show you this. So organisms are present in. Okay, I think yes. Organisms are present in ballast water, which is discharged from a ship. Okay, so 10 organisms are present in 1 meter cube of ballast water. So now A part is asking us. Okay, consider what is the probability. Organisms are present in ballast water discharged from a ship according to a poison process. To consider 10 organisms per meter cube, consider using the poison processes for this purpose. What is the probability that 1 cubic meter, telling us what is the probability that 1 cubic meter of discharge contains at least 8 organisms? So, what is the probability that 1 cubic meter of discharge contains at least 8 organisms? So P of x greater than equal to 8. Okay. So 8, 9, 10. Right? So P of a greater than equal to 8 would be equal to P of x equal to 8 plus P of x equal to 9. So P of x equal to 8 would be how much? So P of x equal to 8 would be, just find it out. Right. Okay. So 8 to the power minus mu. That would be, okay, we need to find a small p, probability of single. Okay, so, wow. Okay, I'm coming in a minute. Coming up in a minute, 1 minute. Okay, guys, let's actually take a small break because we have been doing for such a long time. Right, so let's just take a small break. Okay, just a second. Sorry, I'm doing. Okay, let's guys let's take a small break. Screen capture. Guys, we'll just take a small 5 minutes break. Okay, don't worry about it. If you are watching the video, you can just skip 5 minutes. Yeah, I'm sorry. Okay, I took break of a much more duration, right? So I'm sorry. Let's continue. And because I was tired. Okay. So sorry, right? And we were here. Learning. Okay, so okay, so right. Okay, so let's continue. So it was p of x equal to 8, x equal to 9, x equal to 10. So now if we see here, we in the answer book, the expected number of organisms in 1 meter cube of water is 10. So x is Poisson 10. So greater than 8 is less than equal to 7. So f of 7, 10 is this much. So that's you just use the appendix table. Okay, how the mean is 10? We answer. We ask how the mean is 10. But I will just tell you I don't know. Because the sixth number is 10 organisms per meter cube. Nowhere it's mentioned that it's mean or expected value. Nowhere is it mentioned. Nowhere it's mentioned, right? Nowhere it is mentioned that it is 10. Is it mentioned anywhere? Nowhere is it mentioned it is 10. So right. So how one will know if it is 10? Okay, so let's ask Gemini. It may answer as the right answer because I don't know it. You all can also listen what it is saying. You cannot, you should. Okay, so Gemini, in 86 number question, how is the mean 10?
The concentration is 10 organisms per cubic meter. So for 1 cubic meter, you'd expect a mean of 10 organisms.
No, I'm not telling that. It has taken, this is Poisson distribution. Poisson distribution. So it has taken the mean as 10. So it has a part where we have to find what is the probability that 1 cubic meter of distribution. In part A, it's asking what is the probability that 1 cubic meter of discharge contains 8 organisms. So it's asking us P of x equal to 8. But we are not given the probability, so we can't find the mean. But it's telling us that mean is 10. It's telling us that mean is 10. For finding x, x is okay. So I'm telling you that for finding p of x is greater than equal to 8, we have to we have to we must know, or if you want to find p of x greater than equal to 8, we need to subtract p1 minus p of x less than equal to 7. Sorry, 1 minus right, no, less than equal to 7, I'm right. 1 minus p of x is less than equal to 7. For finding p of less than equal to 7, or for finding PMF of Poisson distribution, we need the value of mean. So here mean is 10. How is it possible? Because it's not mentioned that it's the expected value. It's nowhere mentioned that it is the mean. It's nowhere mentioned it is the expected value. So tell me how.
You got 10 because the problem states there's a concentration of 10 organisms per cubic meter, and you're looking at a sample of exactly 1 cubic meter. For Poisson process, the mean is found by multiplying the rate by the interval of volume.
No, I'm asking you, why is it 10? How do you know the mean is 10? Because nowhere in the question it is mentioned the mean is 10 or expected value is 10. If you want to see, I'm showing you. Where is it mentioned it is 10?
I see why you're asking. The problem states that there's a concentration of 10 organisms per cubic meter. Since part A asks about 1 cubic meter, you multiply that rate by 1, giving you a mean of.
So guys, do you see Gemini is also not Gemini is also not by the way, Gemini, I have Gemini Pro version. Gemini is also not giving us the correct explanation. So as I was telling you, no one can give you the correct explanation. Okay, or let me just try once more what it is saying. I see why you are asking. So it's Gemini has written. I see why you are asking. The problem states that there is a concentration of 10 organisms per cubic meter. Since part A asks about 1 cubic meter, okay, where does it ask about one? Okay. Since part A asks about 1 cubic meter, you multiply the rate by 1, giving you a mean of 10. You multiply, since part A asks about 1 cubic meter, it doesn't ask about 1 cubic meter, Gemini. It asks about what is the probability of getting 8 organisms in 1 cubic meter. But Gemini is, what can I tell you? It asks about 1 cubic meter, you multiply the rate, which is 10, by 1, giving you a mean of 10. You use the extended version of Gemini. Hey, Gemini, it doesn't ask us organisms per cubic meter. It doesn't ask us in part A about 1 cubic meter. It asks us to find the probability that 8 organisms are present in 1 cubic meter. So how is mean 10?
My apologies. The question actually says 1 cubic meter of discharge in part A, which is why the calculation uses 10 as the mean for that volume.
I'm asking again, why is the mean 10? Because because the
The
question
problem
does
says the concentration.
because the question asks about the probability of 8 being in 1 meter cube.
You're absolutely right to look at the details. The problem states there's a concentration of 10 organisms per cubic meter. Since part A asks about 1 cubic meter, you multiply that concentration by the volume, giving you a mean of 10 organisms.
Okay, so guys, let me take a photo. Else, not use Gemini Live, instead take a photo. Ask him. Maybe he can give correct answer. Right, guys. Yes. The mean 10, maybe not expected. Okay, okay, guys, let's move on. Just take the mean as 10. Okay, let's take the mean as 10 and uh, okay, so this one is wrong. Let me just change it. So we have to find p of x is greater than equal to 8. At least 8, so it would be 1 minus p of x less than equal to greater than equal to 7, so it would be 1 minus f of 7 comma 10. We all know the value. You just find it from here of 7 comma 10. 7 comma 10 is 1 minus 0 point double two 0, which is 0.780, is 0.70. Okay, so this is the value. Right? B part. What is the probability that the number of organisms in 1.5 meter cube discharge exceeds its mean value? Okay, so this is an easy question. So just wait a second. I need to call one person. Just a second. Okay, guys, let's continue. Right. So this is 0.4914. Let's move on to. Okay, sorry. Yes. So this was 0.780. So let's move on to the part B. What is the probability that the number of organisms in 1.5 meter cube of discharge? Okay, so now it's telling us what is the probability that the number of organisms in 1.5 meter cube discharge or discharge exceeds its mean value by more than 100 days. So more than exceeds its mean value by more than exceeds its mean value by more than, I'm writing it, I will just show you. Okay, by more than one exceeds its mean value by more than one standard deviation. I think if it exceeds, then it would be just greater than simple, not greater than equal to, right? Yes, so I'm just thinking a bit. Just a second, is it on? Yes. So probability that the number of organisms in 1.5 meter cube. 0.5 meter cube. So discharge exceeds its mean value by more than 100 deviation. The exceeds its mean value by more than 100 deviation. Okay. So this is what we have to write. This is the value, right? Now it would be, if we move to part B, will be more than 100 deviation. It is probable that the number of organisms in 1 meter cube of discharge exceeds its mean by more than 100. This is mean value by more than 100 deviation. So, what is sigma now? Sigma would be okay. So, yours. So x would be okay. So yours x would be not actually. It would be not x actually. X would be not x because this would be new variable y because it's asking in 1.5 meter cube, not 1 meter cube, right? Because x was organisms, number of organisms in 1 meter cube. So even if it is 1.5, we can convert it to 1 meter cube by. Okay, let us take y as. Let take y as number of organisms in 1.5 meter cube. So if you want to write y in x terms, x was what? In one x was in 1 meter cube. So right. So in 1 meter cube. Okay. So let's not write it as y. Let's write it as if it's 1.5, then it would be 1.5x. Right. So let 1.5x y. Let's write it 1.5x. Okay. Now we'll write it as x sigma by 1.5 plus mu 1.5. Now this would be the term, right? See the solution. Yes. So the expected number of organisms in 1.5 meter water cube is okay. So it did another thing which is also the same, I think. We just divided it by 1.5. He just multiplied it by 1.5. Not just the mean value. Right. Okay, let's just stop it from now. We'll just cover it in part 2. Okay, so bye. I'm actually very tired. Right? So we'll cover it in part 2 because I'm tired. Okay, so bye bye. Right? If you wanted, I'm sorry. Okay, so I'm tired, bro. And sis.